Hello champions, welcome to our Form 2 mathematics lesson. Today we are going to discuss area of quadrilaterals, and this is our lesson number 1 in this area. I'm your teacher, Mr. Wanyeke from Maryhill Girls High School. Welcome. Let us look at the area of a parallelogram. When we talk about the area of a parallelogram, there are 6 important properties we need to consider, and I'm sure they are not very new. Number 1, the opposite sides are congruent, meaning if it is in the parallelogram below, we have side AB has the same length and the same direction as DC. And then the length AD is congruent to BC. Property number 2 is that opposite angles are congruent, meaning they are equal. Like the angle at D is the same as angle at B. Then similarly, the angle at A is the same as angle at C. Property number 3 is that consecutive angles are supplementary, meaning angle A plus the angle at D will give us 180 degrees. Similarly, the angle at B plus the angle at C will give 180 degrees. Property number 4 is that if one angle is right angled, then all the other angles will be right angled, and that will give you a rectangle. Property number 5, the diagonals of a parallelogram bisect each other. They divide each other into halves. Property number 6, each diagonal of the parallelogram separates it into 2 congruent triangles. So if we drop the diagonal from B to D, then we'll have 2 equal triangles, triangle ABD and triangle BDC. And if we drop one from the diagonal A to C, from A to C, then we'll have 2 congruent triangles, that is triangle ABC and triangle ADC. Now, we shall use those properties, the 6 properties of a parallelogram, to find its area. And the first one is that if we want to get the area of a parallelogram, then we can truncate, or we can cut one of the triangles as shown, the one in the yellow. We can chop off that part of the triangle and map it onto the other side. You can follow the green arrow. We chop it along the red line, and then we map it onto this other space, and then we can get a rectangle. And therefore, if we have the height of the parallelogram, and we have the base, which is the side of the longer side of the parallelogram, then we can say the area can be given by base times height. Base times height. For instance, in this example, the base is 8 centimeters and the height is 7 centimeters. And therefore, the area of this parallelogram is 8 times 7, which is 56 centimeters squared. Note, this is coming from if you chop off the rectangle, or one of the triangles, and then map it to the other side, then you end up with a rectangle whose area is length times width. But because here we are not dealing with a rectangle, we are dealing with a parallelogram, then we'll talk about the height, which is in this example is 7, and then the base is 8, giving us the area as 56 centimeters squared. Now, using that formula for the area of a parallelogram, then we can do 2 examples. In example A, we have a parallelogram whose length is given in inches, and the height of one is 4 inches, and the base is 5 inches. The other side of the parallelogram is 4.5 inches. So we are interested with the height and the base. So the height is 4 inches and the base is 5 inches. So the area of this parallelogram will be base times height, which is equal to 5 times 4, which is giving us 20 inches squared. In example B, the shape or the direction of the parallelogram doesn't matter. What will matter is, do we have the height and do we have the base? So in this example B, the height is 3.5 and the base is 2. centimeters. So the area will be base times height, which is 2 times 3.5 centimeters, which is going to give us 7 centimeters squared. Also use the area of a triangle in trigonometry to find the area of a parallelogram. Remember we said in the properties of a parallelogram is that if we divide the parallelogram along its diagonals, then we are going to have two congruent triangles. Now each of these triangles area can be found by using the formula a half AB sine theta. Now let us look at example 3 to establish how we can use trigonometry to get the area of parallelogram. We are going to use this example, this parallelogram that has a length of 82 centimeters and 35 centimeters, and we have an included angle or angle at A as 37 degrees. Remember, triangle A is the same as triangle B in terms of size and shape, and therefore they are congruent. So triangle A is congruent to triangle B. So the area of this parallelogram, which is ABCD, will be equal to the area of the two triangles. That is the area of triangle ABD plus the area of triangle BCD. But the two triangles, we have said they are congruent, therefore they are equal. So if you get the area of one, then we just multiply by 2 to get the area of the whole parallelogram. Now in this case, the area of triangle A is, which is ABD, will be given by a half AB sine theta. Now our one side is 35, that is A, and our B is 82 centimeters, and therefore the area of this triangle will be a half times 35 times 82 sine 37 degrees, which is going to give us 863.60 centimeters squared. And therefore, the area of this parallelogram, ABCD, will be equal to the area of one triangle multiplied by 2, which is 863.60 times 2, giving us 1,727.21 centimeters squared. And therefore we can say area of a parallelogram is given by twice a half AB sine theta, where a half AB sine theta is one triangle, and the parallelogram is made by two triangles, and therefore the area of the whole parallelogram will be 2 times a half AB sine theta, which when you cross multiply, you get by 2, 1 by 2, 1, you get that this is giving us AB sine theta. And therefore, the area of a parallelogram, if you are given the angle and the two sides that make that angle, then you can say it is AB sine theta. AB sine theta. So we can use that idea to look at example 5, the next example, that is example 5, 6, and 7. And in example 5, we have the angle given there as 63.4 degrees, and the two angles that make that angle, which is 11.2 and 20. So the area of this parallelogram is AB sine theta, which is 11.2 times 20 sine 63.4, which is giving 200.29 square units. Example 6, we have the other angle given. You have two sides, but we don't know theta, and we know we want angle theta. So for us to know angle theta, we need to know that, use the property of a parallelogram, that consecutive angles are supplementary angles, or they add up to 180 degrees. And if one of these angles is 120, as shown here in this diagram in the example 6, then the other angle theta must be 60 degrees, so that 60 plus 120 will give you 180. So the area of this parallelogram is 8 times 15 times sine 60, which is 103.92 square units. Example 7, we have the area given, an angle 75 degrees, and one of the sides of that angle is 18. Now we want to find the length of B. the other length that make that angle 75 degrees. So we just plug in what we have, and then we find out what is missing. So we say area of parallelogram is given by AB sine theta, and therefore B times 18 times sine 75 is going to give us 120 square units. So we say B times 17.39, that is after getting sine 75, is equal to 120. And then we say our B will be equal to, you divide both sides by 17.39, will be 120 divided by 17.39, which is giving us 6.9 units. So the length of side B is 6.9 units. So any item can be missing. The area can be missing, the angle can be missing, and one of the sides can be missing. So once you have the formula, the area of a parallelogram is AB sine theta, then you can always find whatever is missing. In the event that we don't have any of the angles given, we only have maybe a diagonal given and two sides given, then we can use the Halves formula to find whichever angle is missing. In this example 8, we have the parallelogram A, B, C, and D, and we have the two triangles, triangle A and B. Remember we said the diagonal will give us two congruent triangles of the same shape and size, and therefore the area is the same. So in this case, we are going to use Heron's formula because we have three sides only given, and then multiply that by 2. And then we simply say half of the perimeter, and then we calculate the area of one triangle and multiply by 2. And when we add and divide by 2, our s coming to 48. And when we apply the Heron's formula, the area of one triangle is coming to 336 centimeters squared. So the area of the parallelogram will be twice this. So it will be equal to 336 times 2, which is giving us 672 centimeters squared. For instance, we can look at one example here, example number 1. If you are given this triangle whose sides are 4, 5, and the other side is 6, we can use the Heron's formula to get its area. And the first thing, or step number 1, is to get the value of S, or the half of the perimeter or semi-perimeter, because the perimeter of this triangle will be 4 plus 5 plus 6, and then that gives you 15, and then you divide that by 2, you get that S is equal to 7.5. Once you get that S, step number 2 now is to get your formula, which was the square root of S into S minus A into S minus B into S minus C. And here in this case, we have established in step number 1 that S is equal to 7.5. So when you put it into the formula, then our expression now shall be the square root of 7.5 into 7.5 minus 4 into 7.5 minus 5 into 7.5 minus 6. And then we get the square root of that. You use a calculator, then you find that it is a 9.9. So the area of this triangle is 9.9 units square. Let us now look at the rhombus. The properties of rhombus as follows. All the four sides are equal in length, so it's like a twisted square, and all the internal angles equal to 90, so the angles at the point where the diagonals meet, or we can say the diagonals meet at 90 degrees, and the angles they produce there are right-angled triangles of right-angled triangles at that particular point of intersection of the diagonals. So the diagonals cross each other at their midpoints, or in other words, they divide each other into halves, and the diagonals are perpendicular to each other. Please don't forget that. The diagonals are perpendicular to each other. Remember, in Cartesian plane, this one also comes in handy when you know that the diagonals of a perpendicular of a rhombus bisect each other at 90 degrees. They divide each other into halves and they meet at 90 degrees. Then something that we need also to know, very interesting, is that these diagonals will produce 4 equal right-angled triangles. They produce 4 equal right-angled triangles. And this property is very important in our lesson today because we are looking at the area. So let's move on. Let us now consider a rhombus whose diagonal length from C to B is P units and from A to D is Q units. Remember we've said a rhombus can be divided into 4 equal right-angled triangles if you intersect the diagonals. Remember you said the diagonals bisect each other and they will produce 4 right-angled triangles that are equal. So in this case, the area of a triangle, we know it's a half base times height. And in this case, if the diagonal is P, then half of it is half P. And the other diagonal, AD, which is Q, half of it is half of Q. Therefore, the area of one right-angled triangle will be a half base times height. The base here is a half P and the height is a half Q, and therefore the area of one right-angled triangle will be a half times a half P times a half Q. That gives us 1 over 8 PQ as the area of one right-angled triangle. But this rhombus is made up of 4 right-angled triangles. So we say the area of the rhombus will be 4 times 1 over 8 PQ. And when you simplify that, it's going to give you the area of the rhombus as a half PQ. A half PQ. Remember, P is the length of one diagonal and Q is the length of the other diagonal. For example, in example number 9, you're going to find the area of the rhombus XWYZ below, given its diagonals are 3 centimeters and 4 centimeters long. So meaning one of the diagonals is 3 centimeters and the other diagonal is 4 centimeters. And therefore, the area of this rhombus will be a half times 3 times 4. That is giving you, will give us 6 centimeters squared. 6 centimeters squared. So you can say the area of a rhombus is the product of its diagonals times a half or divided by a half. So we can have example 10 here. Find the area of the rhombus whose diagonals are of length 16 centimeters and 12 centimeters. So it's quite easy. So it is half of 16 times 12, which is giving us half times 16 times 12, which is 96 centimeters squared. We can also use the area of a triangle in trigonometry to find the area of a rhombus, just like in the parallelogram. Remember, the rhombus is made up of 2 triangles which are congruent, and the area of one triangle is a half AB sine theta, and therefore if we know one side, because we know the sides of a rhombus are equal, for example, in the example here, if one side is 6, or the other side will be 6 for a rhombus. So if we have one angle included, then we can be able to tell the area of the rhombus. So in this case, it is 2 triangles, and one triangle is a half AB sine theta, and therefore 2 times a half AB sine theta is giving us AB sine theta. But for a rhombus, the sides are equal. So our A and B are the same. So for instance, in this case, our A is 6 and our B is 6. So for a rhombus, AB sine theta will translate to A times A sine theta, which is A squared sine theta. So for a rhombus, area of a rhombus can also be given by A squared sine theta. A squared sine theta. For example, in this case, our example number 11, using this rhombus, the area of the rhombus will be 6 squared sine 60, which is 31.18 centimeters squared. So in summary, we can say for a rhombus, area can be given by a half the product of the diagonals, a half d1 times d2, a half times diagonal 1 times diagonal 2. Then the rhombus can also be given by A squared times sine theta, where A is the length of the side of the rhombus. Remember, the rhombus has got equal sides. The sides have the same length, and therefore we are saying, instead of saying it is twice a half AB sine theta, then it becomes what? AB sine theta. But A and B are equal, therefore A is equal to B, and therefore the area of rhombus is A squared times sine theta, or A squared sine theta. Remember, theta is any interior angle of the rhombus. Students, we have come to the end of our lesson today. I hope you have learned about the area of parallelogram and the rhombus. And here is some work for you to do. Attempt the questions and post your work to the Google Classroom platform. And make sure that the images of your work are very clear. Do your work on time before 8 p.m. tonight. At the end of the last page, we have the answers for the previous work, for the previous lesson. Please mark and do corrections. If you have any question in these lessons, you're always free to ask. Have a blessed day.